Okay, what I want to do in this, the beginning of this playlist, so this is going to be the first video in a playlist that deals with drawing what are called Lewis formulas of molecules. And a Lewis formula is what we call a structural formula. And it's important in chemistry because structural formulas show us how the atoms are connected in a molecule. And if you remember back, if you've been following my stream of videos, I did a series on the difference between molecular formulas or molecular compounds and ionic compounds. And structural formulas are important for molecular compounds. And these represent a class of chemicals that whose chemical reactivity is dependent on the structure of the particle. So what do I mean by that? So over here I have two examples. I have water, and this is the chemical formula of water, the way it's represented, H2O. And the structural formula is going to look like this. So we have the oxygen, and then the oxygen's bonded to a hydrogen on one side and a hydrogen on the other, and then there are going to be what we call two pairs of unshared electrons. So this in this form, this is the structural formula that demonstrates how these atoms are actually connected to make the molecule. And like I said, this representation is important because it's this structure that actually determines two things with these kinds of compounds. There are physical properties and their chemical properties, how they react with other molecules. Now, this ability or skill is taught in first year general chemistry class at the university level, but if you're sitting here watching this video right now and you're on track at some point to go to medical school or something like that, then what's sitting between you and inevitably that day is going to be a year of organic chemistry. And so this skill, this ability to draw a structural formula is going to be very, very important to you. So for example, drawing the water molecule is pretty easy, and we're going to go through a set of rules, and we're actually going to start with this one because you in order to be good at this, you've got to start at the very beginning. But ultimately you're going to need to be able to look at a molecule like this. This one is acetic acid, which is called it's a general class of compounds called carboxylic acids, and you're going to need to be able to easily draw its structural formula, which looks like this. And you're going to need to be able to do that about as easy as I just did it. So the point is that how do you get from being able to draw something like a water molecule to something that is like this? And so that's what the goal of this series of playlists, or what this playlist is going to be all about. All right, now you'll notice when we look at these two molecules that you can identify the two kinds of electrons in molecules. So the first thing I want to remind you about is that in molecular compounds, which structural formulas are specific to, the main type of bonding is called covalent bonding. All right, I'm going to write that down, covalent bonding. And in covalent bonding, the glue that holds the atoms together, that links them together, is the sharing of electrons. So electrons are shared in a covalent bond. Now, I'm going to designate these two types of electrons two different ways. So I'm going to go ahead and define right now for us that one covalent bond, is going to be equal to 1 dash. All right, so we're using this dash to indicate one pair of bonding electrons. One pair of bonding electrons. That's what the dash means. Right? One pair of bonding electrons. And you'll notice that the other type of electron, which I'm drawing an arrow to here, is shown by 2 closely paired dots. And this is what we call an unshared pair of electrons. Unshared pair of electrons. So we can draw a major conclusion from this, and that is that in any given molecule there's always going to be 2 kinds of electrons that are involved in the total global bonding event. There are going to be the electrons that actually cable the atoms that are connected in the molecule together. These are going to be your dashes, all right? And then there are the unshared pairs of electrons, which are also involved in this, but in a different way. These are the unshared pairs of electrons that will be located on the atom. Now, there's another thing that you can see here when you look at these molecules and you count the electrons that are around what I'm calling the central atom. So let me draw another arrow to this oxygen here. We're going to call this a central atom. All right, and you can see that phenomenon in the other molecule as well. Actually, I'm going to redraw this other molecule so it's bigger. Make it more clear. All right, so this issue of central atoms, so let's go to the more complex molecule and just talk about that for a second. So you can see in the more complex molecule that there are actually several central molecules, and I'll draw an arrow to them. All right, so we have a central atom here. We have a central atom here, right? This is an oxygen that's bonded to this carbon. It's got 2 unshared pairs of electrons, and then it's actually got what we call a double bond to this carbon. Now, I'll get into stuff like that later, but you can see that this oxygen is central to these 2 pairs of unshared electrons and then this double bond. This carbon's central from the point of view. So this is contextual stuff, meaning that when we talk about a central atom, you have to consider what it's central to. All right, and as we go through this molecule, you can see that in the case of the carbons and the oxygens, they're all central. Like this carbon here is central to this carbon, it's central to these 3 hydrogens, and this carbon, all right, this carbon here is central to this oxygen, and this carbon, and so on. So in molecules, you're always going to have a central atom of one type or another. And what you're going to notice when we count the electrons that are around these central atoms, that the electron count is adding up to 8. Electron total is equal to 8. And we're going to be calling this an octet. An octet of electrons. All right. And at the starting point, this issue of the octet is going to be really important. Later on, we're going to look at some systems where we can expand that number beyond 8. But I'm going to lay the groundwork right now and make a strong statement. So when we have central atoms that are, for example, carbon, oxygen, nitrogen, all right, then there's going to be 8 electrons around them, period. All the time. All right, there's always going to be an octet. Now, when we look at hydrogen, you can see in every single one of these cases, if we come back over here and we look at the water molecule, all right, that the hydrogen is never bonded or next to more than 2 electrons. Okay, so for hydrogen, and this is also very important, hydrogen is always going to be bonded to no more than 2 electrons. No more than 2 electrons. All right, now in this video, what I wanted to do is just lay the basic groundwork for this. And what we're going to do is we're going to learn a system of rules to apply to this, because you know, for someone like me, I have a lot of experience doing this, and I already sort of have these rules embedded in my mind. And so for the expert chemist who's probably standing in front of your room teaching you this, they can skip a lot of the rules because they have developed sort of, let's call it a gut sense for how certain atoms are going to bond. But you're sitting on the other side of this, and what you lack is the experience. So what I'm going to tell you about this right now before we go to the next video is that you're going to need to learn the rules, and you're going to need to start with the simplest molecules, and I'm going to lay these molecules out, and then you're going to need to practice this. And if you're in a course right now, you're going to need to practice this every day when you get home, and before you do anything else, you're going to need to draw the structure of a couple of molecules. And if you do that, if you follow my advice, then by the end of the year you're going to be pretty good at this. And that means that when you get to organic chemistry, university level organic chemistry, the chances are that course will go well for you. Alright, so that's my piece of advice.